everyone. In this video, we are going to practice on how to identify the type of relation if the relation is given in this format. Here we have taken the three different type of relation that is defined on the set of integers. The first relation is take the ordered pair AB such that either A is equal to B or A is equal to minus B. In this case, we can also write B is equal to minus A. Now it contains the element of the form ordered pair AA or A minus A or minus A. How we are getting this form? That is getting from this condition A is equal to minus B. If A is negative, in that case the value of B is positive, and here we are directly substituting the value of B as negative A. The second relation is collect all the ordered pairs where A is equal to B plus 1. From here we can write it as B plus 1 comma B. अब यहाँ पे ये क्या रिफ्लेक्ट कर रहा है? जो फर्स्ट एलिमेंट है इस ऑर्डर्ड पेयर का दैट इज +1 एज कंपेयर टू द सेकेंड एलिमेंट. Third relation says that collect all the ordered pairs such that their sum is less than equal to 3. Now we need to identify whether R1, R2, R3 are reflexive or not. For reflexive, we say that every element of the set is related to itself. It means it contains the element of A, A, that is the ordered pair A, that must be a part of a relation for all values of A. Check it. R1 is clearly a reflexive because it contains such ordered pair in a relation. Now what about the R2? Whether it contains such elements, so substitute V is equal to A, we have A is equal to A plus 1. Whether this is true? No. It means there exists no element that is related to itself. So clearly this is not a reflexive, but it is clearly irreflexive as no element is related to itself. Now what about the R3? R3 is a reflexive. Check करते हैं. So how to check this? Whether A plus A is less than equal to 3. From here we are getting a condition A is less than equal to 3 by 2. Now what does it indicate? It indicates that such ordered pair is a part of a relation when A is less than equal to 1.5. It means there doesn't exist such ordered pair for the element 2, 3, 4, so on. Check भी कर सकते हैं. 2 plus 2 is not less than equal to 3. As it is not the part of relation, it means it is not the reflexive. Because for the reflexive, every element must be related to itself. Now whether it is a irreflexive? No. Why not? Because we need no element is related to itself, but there exists 1, 1 as the part of relation R3. So it means R3 is neither reflexive nor irreflexive. Now whether R1 is a irreflexive? No. Here all the elements are related to itself. It means it is not the irreflexive. Now what about the symmetric relation? Symmetric relation means if AB is a part of a relation, this implies reverse should be there. Now whether R1 is a symmetric, let's check it. If A is equal to B, then the reverse in this case is possible. And in this case, its reverse is this and it is also there. It means clearly R1 is symmetric. Whether R2 is symmetric, if A is equal to B plus 1, symmetric means reverse is there. Reverse is B is equal to A plus 1. Whether this is true? No. It means it is not symmetric. Now what about the R3? As per the R3, the condition says that if AB is a part of relation means A plus B is less than equal to 3. Now whether B is a part of relation means B plus A is less than equal to 3 always. Whether this implies this? Yes. So addition is commutative, so there is a no impact in this case. So we can say that yes, this is a symmetric relation. Now what about the antisymmetric and asymmetric? Antisymmetric means if A, B is a part of relation, then reverse should not be there provided A is not is equal to B. And we say if A, B is a part of relation and you are also saying that B is a part of relation, that is only possible when A is equal to B. So simply we can break this definition into one part, that if A is not is equal to B, then the reverse should not be there. Second, from here we can say that element of this ordered form can be there. It is not required that for every element such ordered pairs exist in a relation, means it can be there or cannot be there. So we will not worry about such elements. We just need to figure out when A is not is equal to B and it is a part of relation, reverse should not be there for the antisymmetry. But in the case of asymmetric, this is different from the antisymmetric. It says that if AB is a part of a relation, then reverse should not be there. In this case, we are not taking any kind of restriction on AB. We just need to check if AB is a part of relation, reverse should not be there. And we will also say that ordered pair of this type should not be there for any element. Now we need to identify whether R1, R2, R3 are antisymmetric or asymmetric. In R1, we are taking the ordered pairs where the first element is equal to the second element. But as per the requirement of the asymmetric, it should not be there. So this is not the asymmetric. Now think whether this is the antisymmetric. Antisymmetric condition says that if AB is a part of relation, reverse should not be there. So take the ordered pair this AB. Its reverse is this and it is there. It means it is not the antisymmetric as well. So R1 is not the antisymmetric as well as asymmetric. For R2, let's check it when A is not is equal to B. So if AB is a part of relation means A is equal to B plus 1. It say that BA should not be there, means B is equal to A plus 1, that is invalid. Whether this is true? Yes, because from here the value of B is equal to A minus 1. It can never be A plus 1. So clearly this condition is valid. Now think whether such ordered pair exists for the R2. No. Why? Because A cannot be equal to A plus 1. So such ordered pair is not there. So from here, this condition is completely valid. Reverse is not there and such ordered pair is not there. So it means R2 is asymmetric. Whether this is antisymmetric? Yes. It says that it can be there. If it is not there, do not worry about this. This condition is valid. So we are satisfied that it is a antisymmetric. Now R3 relation is antisymmetric or asymmetric. For antisymmetric, we say that reverse should not be there. Its reverse will be V plus A is less than equal to 3 and this is the true statement. So in both the cases, the condition is not valid because the reverse is there. So it is not the antisymmetric as well as asymmetric. Now moving towards the transitive. So transitive condition is if the ordered pair AB is a part of relation and the ordered pair BC is a part of relation. This implies the ordered pair AC is a part of relation. Check it whether the statement is applicable in all these three relations or not. Let's start with the third one. If it is a part of a relation, it means it is of the form A plus B less than equal to 3. In this case, B plus C is less than equal to 3, we need to show that A plus C is less than equal to 3. Clearly, this is not the transitive relation. Why? Simply pick the ordered pair as 3, 0. So 3, 0 satisfies this. In this case, the value of B is 0. Take another ordered pair 0, 3. The value of B is same. A value is 3. Here C value is 3. Sum of these two is exceeds the 3. So it means it is not the transitive. So do not take R3 as a transitive. Check whether that is applicable for the R2 or not. Again, that is not the applicable in this case. How? Take any ordered pair that satisfies this condition. Let it be a 2, 1. I can take another ordered pair as 1, 0. Because we need to keep B as the same here. Here the value of A is 2 and the C is 0. So whether 2, 0 is a part of this relation? No. Because the difference between the first element and second is 1. So here we are getting the difference as a 2. So it means it is not the transitive. Now what about the relation R1? If I take this type of ordered pair, it's clearly correct. So let it be a 1, 1. So in this case, we need to fix the value of B, 1. So we can take either same format 1 or we can take the negative of itself, that is minus 1. So final will be 1 minus 1. So such type of element is there. Now if I take of the form 1 minus 1 as compared to the second one, so we need to fix the value of B as minus 1. So possibility for the C is what? That is this, that is 1. Ultimately we are getting a 1, 1 and it is there. Now if I am picking any element of this form, let it be a minus 1, 1. So we need to fix the value of B, 1. Option में क्या है? Maybe negative 1 or 1. If I am taking a negative 1, this is equal to minus 1, minus 1. Is it is there? Yes, it is there. It is not saying that A is always positive here. We are also taking minus A because both the elements are same and the domain is set of integer. So this type of elements are already there in a set. So yes, R1 is a transitive. So this is how we can identify the type of a relation on such type of the defined form.